Okay, section 7.4 is called Applications. It's a rather frightening section because we're going to do a whole bunch of the really hard stuff from earlier in this course, like related rates and optimization and displacement. We're going to do it all in one day. Scary. So we're going to start with the displacement question. It says the position function of a particle is given as s equals 2 sine t minus cosine t between the times 0 and 2 pi. S is displacement, t is time. Find the maximum and minimum displacement. Okay, in order to get this question, you're going to have to realize that that maximum or minimum displacement is going to occur when the velocity is equal to 0. So for example, if here's something moving that goes out to here and then like this, and this is like the maximum displacement here, let's say, there must have been a split second there where it wasn't moving, the velocity was 0. And if this is the minimum displacement, there must have been a split second there where it wasn't moving as well, where velocity was 0. So that's why you're looking for where does velocity equal 0. Now, this is about distance. We want to know about velocity. What's the connection between a distance function or displacement function and velocity? It's the derivative. So you have to take the derivative of this. You have to take s prime, or if you want, you can write it as ds dt. So what's the derivative of 2 sine t? It's 2 cosine t. What's the derivative of cosine t? It's negative sine t. So you get negative sine t. Now what we want to know is when is this velocity, right? This is what the velocity is equal to. We want to know when is this velocity equal to 0. So in other words, we're looking for when does 2 cosine t plus, minus negative is plus, sine t, when does that equal 0? So let's leave the sine t here. We're going to solve this. Leave the sine t here. Move the 2 cosine t over. You get negative 2 cosine t. Let's divide both sides by cosine t. So when you do that on the right hand side, these will cancel. You're left with sine over cos, which is the same as tan. Tan t equals negative 2. Now, I know what you want to do right now, and you could do this. You could take inverse tan and you'll get some crazy decimal answer for your degrees. But I want to show you how you don't actually have to figure out t. What you can do is just take tan t into account. So first of all, since this is negative 2, which quadrants could this be in for tan? Tan is negative in the second quadrant and in the fourth quadrant. So we know we're dealing with those possibilities. The other thing I want to look at is just a reference angle here, right angle. And I want to think if you have a tan value of 2, I know it's negative 2, but let's just think it of 2 because the negative just tells us the quadrant. If you have a tan value of 2, then what has to be true? Well, if we look at opposite over adjacent, because that's what tan means, opposite would have to be 2, adjacent would have to be 1. Opposite over adjacent, 2 over 1 is 2. Great. Well, the good news is we can also figure out this side of this little triangle here. So if this is 1, this is 2, we would have 1 squared plus 2 squared equals c squared. That's 1 plus 4 is 5 equals c squared. So then the hypotenuse is root 5. So we actually have all the information we need now. So we're going to look back up here at this function right here. Going to rewrite it. S equals 2 sine t minus cosine t. After all, we are looking for maximum minimum displacement, and this is the displacement function, so we must be using it. And we got to do it twice, once for the second quadrant, once for the fourth. So I'm going to write quad 2 here to show we're doing the second quadrant. In the second quadrant, is sine positive or negative? Well, remember, angry Serbs take creatine. Second quadrant, sine is positive. So what we have is S equals 2. Now sine t, sine is opposite over hypotenuse. It's 2 over root 5. Minus cosine. In the second quadrant, cosine is negative. And cosine in this case would be adjacent over hypotenuse. 1 over root 5. So 2 times 2 over root 5 is 4 over root 5. Take away negative is plus 1 over root 5. We end up with 5 over root 5. Now, if you rationalize that by multiplying top and bottom by root 5, you're going to end up with 5 root 5 on the top, just 5 on the bottom. Root 5 times root 5 is 5. Those cancel out. You end up with root 5. So that's for quadrant 2. Now we got to do the same thing again, but we have to do it in quadrant 4. So I've rewritten the same function. In this fourth quadrant, is sine positive or negative? It's negative. So it's going to be negative 2, or you can put 2 times negative, but I'll just put the negative here. Sine, well, sine's the same. It's opposite over hypotenuse, which is 2 over root 5, minus cosine in the fourth quadrant is positive, so no negative here. I mean, that's the minus sign, but we're not going to put another negative. Cosine is, just like before, 1 over root 5. So you end up with negative 4 over root 5 minus 1 over root 5. And if you compare it to here, you'll see pretty quickly that you're going to get negative 5 over root 5. You're going to end up with negative root 5. Okay, unfortunately, there's one last thing you have to do. You have to try the endpoints as well. Perhaps those are where the maximum and minimum displacement are. So we're going to use that same function, s equals 2 sine t minus cosine t. One of the endpoints is 0, so we're going to plug 0 in there. We get 2 times sine 0 minus cosine of 0. Sine 0 is 0, so we get 0 minus. Cosine of 0 is 1. 0 take away 1 is negative 1. And finally, we have to find the other endpoint. So again, I mean, I know this is overkill writing this every single time, but what the heck? Our other endpoint is 2 pi. Well, 2 pi is just coterminal to 0, so it's going to be exactly the same thing. If you want, you can write it out again, but it's really not necessary, because you're going to get exactly the same thing. You're going to get negative 1 again. So it's pretty obvious which one our maximum is. The biggest number of this, 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 and this. The biggest number is this one. So this is our maximum displacement right here. What's smaller, negative 1 or negative root 5? Negative root 5, so this is our minimum displacement. Next question is an optimization question. We're going to find the maximum perimeter of a right triangle with a hypotenuse of 20. So let's just draw triangle, right triangle, has a hypotenuse of 20. And we're talking about perimeter. This is what we want to maximize here. So our objective function is going to be perimeter equals, perimeter's all the way around the outside, right? So we're going to need some value here, let's call it x. We're going to need some value there, let's call it y. And the perimeter's pretty straightforward. It would be x plus y plus 20. Remember, however, we want to have just one letter over here. We've got 2 right now, we just want 1. So how are we going to do that? Well, let's put a little angle right here. And we can write a couple statements using trigonometry. We know, for example, that sine theta equals opposite over hypotenuse, y over 20. And we know that cosine theta equals adjacent over hypotenuse, which is x over 20. How will that help us? Well, what we're going to do actually is we're going to change both of these. We're not going to change them both to x or change them both to y. We're going to change them both to thetas. So we're going to isolate the y here. We're going to isolate the x there. Easy to do, right? Just multiply both sides by 20 here. You get y equals 20 sine theta. Isolate the x here. Multiply both sides by 20 again. You get x equals 20 cosine theta. Great. Now what we can do is we can plug both of those into our objective function. So we end up with p equals x, which is 20 cosine theta, plus y, which is 20 sine theta, plus 20. The other thing we want to do before we take the derivative, if we want to look at the domain, how small and how big could these angles be? Well, we're talking about a triangle. The smallest an angle can be in a triangle is just a little bit more than 0. So it has to be more than 0. Theta has to be more than 0. And what's it have to be less than? Well, we already have a 90-degree angle here. So these other two angles have to be less than 90 degrees. Or in terms of radians, pi over 2. Okay, let's take the derivative. P prime equals, the derivative of cosine theta is negative sine, so we're going to have negative 20 sine theta. Derivative of sine theta is cosine theta, so plus 20 cosine theta. Derivative of 20 is 0, so we don't have to write anything there. And why don't we take a negative 20 out? Factor of negative 20. You're left with sine theta minus cosine theta. And what we want to do is we want to get the critical numbers. So we want to see, where does this not exist? Well, it always exists. Where does it equal 0? So where does negative 20 sine theta minus cos theta, when does that equal 0? Well, to start, you could divide both sides by negative 20. This is gone. Next thing you do, move the cosine over. So we have sine theta equals cosine theta. Guess what you're going to divide by? Cosine theta. These are going to cancel, leave you with 1. Sine over cos is tan, so you have tan theta equals 1. Now, our angle has to be between 0 and 90 degrees, between 0 and pi over 2, so we only have to worry about our first quadrant angles. Which angle is it that has a tan value of 1? It's 45 degrees, or when pi over 4 in radians. So we're ready to put stuff on our wiggle graph. We're going to put pi over 4, and we're going to put our endpoints. It goes from 0 up to pi over 2. And we're going to test it. Where are we going to test it? Right here. So why don't we go pi over 6, or 30 degrees here. So sine 30 is 1/2, minus cosine 30 is root 3 over 2. If you subtract that, is it going to be positive or negative? That's going to be negative. Root 3 is bigger than 1. So you got a negative times a negative 20, you actually end up with a positive. So this is increasing. Okay, let's do pi over 3, or 60 degrees here. So sine 60 is root 3 over 2. Cosine 60 is 1/2. It's just kind of the same thing but reversed. So this time you got a big minus a small. You're going to have a positive times this negative right here. You end up with negative. This is decreasing. So what's this mean when something increases and then decreases? It means you have a maximum. And that's what you wanted to find. You wanted the maximum perimeter. This is good news. In order to get that maximum perimeter, we're just going to plug it into the original function right here. So we get the perimeter equals 20 cosine pi over 4 plus 20 sine pi over 4 plus 20. Okay, pi over 4 is 45 degrees. Cosine and sine are the same at that point. They're root 2 over 2. So we have 20 times root 2 over 2 plus 20 times root 2 over 2 plus 20, which equals, these would cancel, and you'd have a 10 here. Same here. So you got 10 root 2 plus another 10 root 2, which is 20 root 2, plus another 20. You could factor out the 20, but I don't think it's really necessary here. So here's your answer, 20 root 2 plus 20, and what are we talking about here? We wanted to know the maximum perimeter, so the total distance around this triangle with hypotenuse 20 is 20 root 2 plus 20 centimeters. That's the biggest perimeter possible. Okay, before we do this last question, I have to introduce you to 2 useful facts. One is this: if you have a triangle where you know one angle and you know the sides adjacent to that angle, there's a way you can get the area. The area is equal to 1/2 times A times B times sine theta. So this is this case here. We have A and B, which are adjacent to the angle. The other thing I want to remind you of is the cosine law when you're missing one side. So let's say you didn't know side A. The way you can find it is you use A squared equals B squared plus C squared minus 2BC times cosine of A. This one you should remember. We've done this before. We never actually used this before. You could figure it out pretty quickly. Okay, let's get to our question. Okay, this is a related rates question. It says we have a triangle of lengths 15 meters and 20 meters. So 15 and 20. And the angle between them is increasing at this speed. So we're not going to label, we're going to label the angle, but just with a theta. We're not going to put pi over 90 because that's the speed, right? That right there is actually d theta over dt equals pi over 90. How fast is the length of a third side changing? So let's call this third side here, let's call it A. We'll call this angle here angle A. And we want to know how fast is this changing. We want to know how much dA dt is. So first of all, what's something that relates all these things here? Well, that would be the cosine law right there, right? We've got our angle A, our side A, our B, and our C, and that's exactly what you see here. So I'm going to write A squared equals B squared. Why don't I put 15 squared there? So this is my B here, this is my C, plus C squared, so that's 20 squared, minus 2 times B, which is 15, C, which is 20, cosine of A, I'll call it theta. So A squared equals 225 plus 400 minus 2 times 15 is 30 times 20 is 600 cosine theta. So A squared equals 625 minus 600 cosine theta. And remember, what you now do is you're going to differentiate both sides of this with respects to t. So if we take the derivative of a squared, you would get 2a, but then you're going to have to write dA dt equals, the derivative of 625 is 0. That's fine. The derivative of negative 600 cosine theta. Well, the derivative of cosine is a negative sign, so it's going to be negative negative, or positive 600 sine theta d theta dt. So we're going to plug in everything we know here. We know 2a, we don't actually know, so I'm going to leave a space here. dA dt we also don't know, and that's the thing we're trying to figure out, so that's going to be our only unknown. 600 sine theta. Well, it tells us we're interested when the angle is pi over 3. So we want sine of pi over 3. And then d theta dt, I believe we have right here, pi over 90. So the problem is this a here. We got to figure out a. Now, how are we going to figure that out? Well, it tells us this information that when the angle between the sides is pi over 3. So I'm going to actually draw this drawing here again, but this time I'm going to put my 15, I'm going to put my 20, but this time I'm going to talk about this specific time when it's pi over 3. And what I need, remember this is my angle A right here, I need to know this side right here. Can I do that with this information? Sure can. How can I do it? The cosine law, again. So this time we got specific numbers, we're going to use the cosine law. A squared equals b squared plus c squared. Well, it's going to be 20 squared plus 15 squared again. It's going to be 625, just like before. Minus 2 times 15 times 20. That's going to be 600 again, just like before. Cosine of pi over 3. So that's 625 minus 600 times pi over 3 is 60 degrees, and cosine of 60 degrees is 1/2. So that's very nice. So we get 625 minus 300, which is 325. And remember, that's how much a squared is. So our a is equal to the square root of 325. Hey, let's put that in simplest radical form. How about, what goes into 325? Well, 25 does. 325 is the same as 25 times 13. You can take the square root of 25, which is 5, and you're left with root 13. So this is root 325 in simplest form. Do a tree if you don't know how I did that, but 5 root 13. So that's the number that goes in right here. And now what we have to do is isolate this dA dt, and we'll be done. So 2 times 5 root 13 is 10 root 13 dA dt equals 600. Now sine pi over 3, that's 60 degrees, and sine 60 is root 3 over 2. I'm going to multiply that by pi over 90. So I'll leave this over here for one more step. I mean, you do this whichever way you want, but I'll do it like this. Let's see, I could simplify the 2 and the 600 and get 300. I could also knock 0 off of both of these. I could divide them both by 10, so I'd have 30 and 9. And I could also divide them by 3, so I'd have 10 and 3. Sure hope you can follow that, everyone. So what I'm left with is 10 root 3 pi over 3. And now what I need to do is I need to divide it by 10 root 13. So I have dA dt equals 10 root 3 pi over 3 divided by, or I'll multiply by the reciprocal, so 1 over 10 root 13. Well, the 10s can cancel. So I'll just rewrite this. I have root 3 pi over 3 root 13. And that's a pretty good answer. It's great. You could rationalize the denominator here, and you get pretty, it's pretty complicated as well. But how about this? This is a pretty cool little thing you could do. You could rationalize the numerator here. Now, if you don't notice this, don't worry. It's not a big deal. But if you rationalize the numerator, you get root 3 times root 3, which is 3 pi over 3. Now, root 13 times root 3 is root 39. Why is that nice to do that? Because look, 3 and 3 are gone. We end up with the answer pi over root 39. If it's hard to make sense of that answer, you could put it in your calculator, but this is awesome. This is the best answer, pi over root 39, or rationalize that if you want. and you end up getting 0.503. Now, what are we measuring here? What are we looking at? How fast is the length of the third side, which is in meters, changing when the angle between the sides is pi over 3? Well, it's in seconds and we're in meters, so we have 0.503 meters per second is our answer. Or even better, pi over root 39 meters per second. Very, very hard section. Good luck with it, everyone. We'll spend a couple days. I will help you.